Thanks to Skillshare for supporting this episode of Journey to the Microcosmos. The first 1,000 people to click the link in the description can get a free trial of Skillshare's premium membership. Mermaids are apparently not real, but depending on how loose you are with your definitions of fantastical creatures, we could be convinced that rotifers are a little like microscopic mermaids. Yeah, they don't have any particularly human resemblance, but like sailors of old might have confused sea creatures that they saw with the fantastical creatures in their heads, there's something kind of fun about imagining the rotifer as our own little mermaids. But rotifers do have something that the famous Little Mermaid didn't have and so desperately wanted. What's the word? Oh, right. A foot. It's that long thing on the end, which on any other animal we might call a tail, or on a mermaid a fin, and at the end of the foot is a toe, through which the rotifer produces a cement-like substance so that it can glue itself to other surfaces. Of course, the foot of a rotifer is not actually a foot in the way that we think about feet, nor is the toe a toe in the way we think about toes. But it's hard not to peer into the microcosmos and see the structure of things familiar, even if not exactly the same. Take, for example, the ciliate. As we have seen often throughout our journey to the microcosmos, ciliates may just be composed of one cell, but they can put that one cell to great use, taking on many shapes and forms that act in magnificent ways. The defining feature of ciliates are the hairy cilia that covers them. For some, that's a general fuzziness that covers their whole unicellular body, but for other ciliates, those cilia bundle together to form a structure called cirri. With all those hairs working together, the cirri is more like a limb that helps the organism move around. The effect for some species is that the ciliate looks almost like a weird misshapen centipede as it creeps along the slide. Of course, there are organisms whose legs and feet are actual limbs, like our favorite tardigrades, whose bumbling bodies include 4 pairs of legs, 3 along the trunk and another right towards the butt end of the tardigrade. At the end of those legs are claws, and that means that yes, depending on the angle, sometimes it looks like tardigrades do have little butt claws. Oh, and what a variety of claws they have. Describing just one singular shape of claws for tardigrades would be tough because there are just so many different ones out there, so much so that claws are one of the features used to distinguish between different species, whether that's by assessing the size of them, the number of them, or how they are attached to the tardigrade's legs. Because tardigrades live in many different environments, whether that's water or moss or soil, their legs and claws are adapted to suit their home. Those that live in soil tend to have shorter legs and shorter claws than those living in fresh water or on mosses, possibly to help them fit better in the small spaces available underground. And some tardigrades have lost those hind claws entirely, which sounds a bit sad because just think how cool it would be to have butt claws, but that's a small price to pay for comfort and survival. Feet and legs have a purpose. They help organisms move around, but feet can also play a different role altogether. If we switch up the scale we're looking at, they can serve as a home. If you've ever gotten a whiff of a smelly foot, well, you're probably smelling the leavings of bacteria. You'll notice this particularly when you've been wearing shoes that aren't well ventilated, which makes your feet sweaty and converts them into a nutritious, watery world for microbes. As the microbes metabolize the nutrients that your feet have expelled, the bacteria produce compounds that just aren't that great to sniff. And then, of course, there are the more nefarious means of foot life. This is a mite, and it is beautiful in that creepy, unsettling way when it is still. but watching it crawl across the screen kinda makes it cute. Well, cute until you remember that there are species of mites, like the scabies mite, that use their front legs to dig into the outer layer of your skin and lay their eggs. And yes, that includes the skin of people's feet. Mites aren't the only parasite that finds their way into a host through feet. If you want to continue to be unsettled, you can look into parasitic worms that have taken advantage of the proximity of feet to find their way into human bodies. Now, we could end on that unsettling note, but instead, let us revisit our microscopic mermaids from the beginning of the episode, the Rotifer. As we said, the Rotifer technically has a foot, but it's not actually a foot. In some ways, it's kind of the opposite of a foot. It keeps the Rotifer anchored to one place instead of helping it move around. But Rotifers are also happy to take advantage of other animals' feet for transportation. A few years ago, a group of scientists obtained some duck's feet from a local butcher and then pressed them into samples of sediment to see how well they could be a vector for Rotifer dispersal. Well, it turns out they can, though they are probably not as effective at spreading Rotifers around the world as something much more simple and less animate, the wind. There are many of these invisible mechanisms for transporting microbes around the world, whether that is through the feet that trod on the ground or fly through the air. If you look up in the sky, what you're seeing there may be a bird, or, invisibly, it may be a rotifer, with its foot attached to a foot, attached to some wings. Thank you for coming on this journey with us as we explore the unseen world that surrounds us. If you'd like to add some additional microbes to your feet, you can get a pair of paramecium socks over at dftba.com. And we'd also like to say thank you again to Skillshare for supporting this video. Even if you've already picked up a pair of your paramecium socks, one pair of socks is never enough, and with Skillshare, you can learn how to make your own. Among the many, many helpful courses you can find on Skillshare, there is Cozy House Socks, An Introduction to Sock Knitting, hosted by Whitney Hayward, where you will learn how to take your knitting game to the next level by making a pair of cozy, thick socks to keep your toes warm around the house. Skillshare is an online learning community that offers membership with meaning, with so much to explore, real-world projects to create, and the support of fellow creatives. Skillshare empowers you to accomplish real growth. It's curated specifically for learning, meaning there are no ads to distract you, and they are always launching new premium classes, so you can stay focused and follow wherever your creativity takes you. And an annual premium subscription to Skillshare is less than $10 a month. If you're one of the first 1,000 people to click the link in the description, you can get a free trial of Skillshare's premium membership. The people who are on the screen right now, that's a bunch of names. And those people are the reason that we can make weird videos about microbes and feet. We are very happy to be able to do it. It is one of the joys of our life. And you are the reason that that's possible. If you'd like to help us reach more people and find more cool things in the microcosmos, you can support this show at patreon.com/journeytomicro. If you want to see more from our master of microscopes, James Weiss, you can check out Jam and Germs on Instagram. And if you want to see more from us, there's always a subscribe button somewhere nearby.